Welcome back to our new class of AI, machine learning, data science, and big data analytics. The topic of this class is going to be Introduction to NumPy with NumPy arrays and operation. Well, I have segmented this class in specific ways and specific parts so that it is easier for you to learn. I also have some specific objectives that I want to complete in this class so that you get a clear and vivid idea about what these are and how are you going to use them by using PyCharm or any other IDE, and how is it going to help you in AI, machine learning, data science, and even data analytics. So first off, let's open up PyCharm on our device. And if you're not using PyCharm, if you're using VS Code or any other IDE, first off, let's open it up and we're going to learn about what is NumPy first, and then we're going to get into our practical part of this class. So as you can see, I have opened up PyCharm. Now, the first and the most important thing that we have to know is what is NumPy? Well, you can term NumPy to be a module of Python, even though it is a module of Python, but it is a very popular one. So NumPy basically means numerical Python. So the foundation of how NumPy was created is basically for data science, machine learning, deep learning, and also big data. It is basically used for mathematical operations a bit faster than the default Python. It can also handle a very vast and large amount of data sets, and also for computing scientifics or even, let's say, scientific operations. So now you might think, why NumPy? Like, there are also a lot of other modules in Python. NumPy, or why is it advantageous? It is because it is a lot faster than using default Python list. If you want to use vectorized units or vectorized measurements, it basically helps you to process data in bulks a lot faster and also for error handling. It can also support multi-dimensional arrays such as vertical, horizontal, depends on the user's needs. And the last and the most important thing is that it can also work with other modules such as pandas, scikit-learn, TensorFlow, PyTorch, and etc. So the first and the most important thing, what we're going to do over here is we're going to create a new project. So first off, click on New Project. There we go, we have created our project over here. Now we're going to inherit the packages from base interpreter and make available to all the projects. And also make sure you have Python installed on your device, as you already have if you have followed up my classes up till now. Okay, now what we're going to do is we're going to just press on create, and we're going to wait until the interface opens up on our screen. So right after pressing on create, you can see it is updating the skeletons. It is also going to index all the modules so that we have Python, perfectly running and functional on our interface. Okay, now we're just going to wait for a bit until this part is updated, because that is very important so that the whole IDE is functional with Python. Now, after this is done, what we have to do is we're not going to create anything like a Python file, or we're not going to start, the practical part, but instead, the most important thing is that, just like I said, NumPy is a module of Python. So we have to install that first on our IDE. Now, I've also shown you that there are different methods of installing IDE, either from the terminal or either from here. But I prefer using this, so I'm just going to open up the terminal, and here I'm going to type in pip install NumPy. Hit on enter and wait for a bit. You will see there is a syntax warning, but it is going to install and download whatever is needed to make sure that NumPy is functional on your IDE, and also it works with Python properly. Okay, so let's just wait for a bit, and also make sure you are connected to the internet most of the time, because that is very important. There we go, it has collected the package, which is NumPy, and there we go, it is done. Now you will see that it is going to index for a couple of seconds, and after that you are basically good to go. And first off, after this, you want to create your let's say, the Python file. Okay, so just like I said, that it works with large data sets, so it is kind of like a listed data. Now obviously I've shown you how lists work in Python, but whenever you are working with big data sets, machine learning, or even data analytics, make sure to use NumPy, because that is a lot better and a lot faster. So here, let's create our Python file. Let's say I'm going to make sure to name it example1. There we go. You can see we have example1 PYI. It's totally fine, but you can also put in PY. Okay, it's basically up to you. You can see if I put in new Python package, example2. There we go. So let's just use example2, and I'm going to delete this example1 because I don't need it. Delete. There we go. So we have example2 opened up over here. Now, first thing that we need to learn about is that whenever you are using NumPy, it basically needs a specific list. Now, if you still don't know how does a list look like, we basically use the secondary bracket, or known as these, the square bracket. Let's say I'm just going to put in lists, or p underscore list equal secondary bracket and 1, 2, 3, 4, 5, whatever type of data it is. This is basically a list. But we don't want to work like this. Instead, we want to use it as an array of data. So whenever you are working with array, including NumPy, what we basically do is we put in, first off, import NumPy as NP. And then we put in the array. So 1. Now I'm going to put in 1. I'm going to put in example underscore array equal np dot array. There we go. Whenever you define np dot array, NumPy is called. So np array, open parentheses first, secondary bracket, and now we can define 1, 2, 3, 4, 5. There we go. In this way, an array has been created. You can put in D types if you want to, but I'm just going to put in the list. That's it. Okay? Now here, let's say I'm going to print it out in a form of array. So I'm going to put in example array and run the whole thing. That's basically it. When you print it out, you will see it is going to print out just like this. So that is basically a NumPy array. Okay? Now that you have seen the array, let's also put the same thing in rp lists equal 1, 2, 3, 4, or whatever it is. Let's just keep it up till 5. And I just want to print it over here. Print PR list. Let's just run this. And there we go. Now you can see both of them has been printed. The first one is a NumPy array, and the second one is basically a Python list. Now there are a couple of differences that you can already see, is that in a list, the commas are visible, but in the array, the commas are not visible. Okay? So one thing over here is that there are a lot of difference. In a Python list, the speed of it to work and process is a lot slower, while the NumPy array is basically much faster than the Python list. The storage of Python list is a bit slower and a bit scattered. But the NumPy array, or whenever you are working with NumPy array, it is a continuous memory. So it doesn't give you any error, and it just keeps on printing, keeps on processing without facing any problem. In a Python list, you might see that sometimes there are some loops that are needed. You cannot work with it, you cannot print it, you cannot see it on your console. But when you are working with NumPy array, the measurements which you have are basically vectorized. So the measurements are super accurate and without any error. In that way, it doesn't give you any problems, and it can work with a large data set and give you the exact measurement. And also, when you are working with Python list, sometimes you can work with a lot of mixed type of data, such as you can use strings, you can use, numerical data, float data, you can use like, integer, all of them. But when you are using NumPy array, it can only use these integer and float values. It cannot work with string values. If I put in, let's say, word or double quotation word, let's print this out. You can see we have word over here. But when you are trying to do an operation, it is not going to work. So it's only going to validate the same type of value. This word that I have put in, even though you can see in the previous one, there was no quotation available. So if I just remove this and put in 3 again and run the program, you can see there is no quotation on any of them. Because when I put in the string value inside, all of them turned into a string value. So we cannot work with any operations then. But if we just remove the string from the float or the integer, it will only work with string, or let's say not string, but integer values. So you have to keep that thing in mind, is that NumPy array validates only one type of data inside the array. Okay? Now, let me also give you a couple of proof that why NumPy is a lot faster than Python. Okay? So let me just open up another Python file. So I'm going to put in test. First things first, I'm going to put in import NumPy as np, import time, so we can check what is the difference. First off, I'm going to have the py_li, which is the list. So I'm going to have a list and a specific range. Let's say 2_00_000. And I'm going to put in np_arr equal np.array. Open it up, and here I'm going to, let's say I'm going to put in the py list. So we have the exact same data. Now I'm going to put in start equal time dot time to make sure that the function works properly. I'm going to have the py list that is going to be over here equal. Now we're going to put in the secondary bracket. Let's say I'm going to put in x multiplied with 2 or 3 for x in the py list. On the next one, I'm going to put in print, let's say listing time. Okay, put in comma, time dot time, parentheses, put in minus, and then I'm going to make sure it starts up the function. I'm going to put in start equal, put in time dot time, open the parentheses. I'm going to put in np dot array, which is going to be just underscore array, np underscore array again, but it is going to be multiplied with 3. The same operation. And here I want to print out, let's say, NumPy time, comma, say time dot time, open the parentheses, minus the start value. That's basically all that you need to do. So this is going to be our function. Now let's try running the whole thing. And you might see that there is an error over here. We're going to check which line it basically is. Line 13. We have time, comma, time. So I'm going to put in time.time. Run this program. And there you go. We have NumPy time, which took like 0.00 and then 4. But the listing time took like 0.1380. So that is a lot lesser than this one. Even though this is a very small process or a very small operation, that's why it took a lot lesser time. But if it was a very big data set, then it would have taken a lot of time and we would have seen a lot of difference. But as you can see the number, NumPy time or NumPy takes a lot less time than Python listing. Okay, so there we go. We have the proof over here, which is going to help you to understand a lot better. Now, next thing is that we're going to learn about arrays. Now, what are arrays and how are you going to create the array in Python? Okay, so first of all, let's create another Python file. Let's say array1. Okay, so first things first, what I'm going to do over here is that I'm going to import NumPy as np. Now let's create a variable. X is going to be equal to np.array, open the parentheses, secondary bracket, let's say 1, 2, 3. And I want to print out X. If I print this out, the array is printed. Now, what if you want a multi-dimensional array? In that case, what we can do is we can open up or go onto the secondary parentheses. Now, one thing is that I'm going to make sure I put in 2 parentheses or 2 secondary brackets. And also, after this, I'm going to put in a comma. There we go. Now over here, I'm going to make sure to put in another secondary bracket. Here, let's say 4, 5, and then 6. Now let's just close this off as we have 2 secondary brackets. There we go. Now, if I want to print out the exact same thing, I'm just going to run this, and there we go. We have 2 arrays or multi-dimensional array. Okay, and you can see there are no commas to differentiate the value. Now, we're going to also learn about how you can put in arrays with zeros. So, let's say we're going to put in zeros equal np.array parentheses, 2 parentheses basically. Let's say 4, 5. Now we have 2 parentheses open. If I want to print this out, let's say zeros, run the program, you will see we have 4 and 5 at the end. Okay? So even though this is not like, a total 0, but there are no zeros over here, and also it starts from the beginning. Okay? Which makes it a lot more easier for you to understand. Now, what if you want to print it out with ones? If you want to print it out with ones, you can do that. It's basically just changing the variable. So, let's say ones equal np.array, open up the parentheses again, and here, let's say I'm going to put in 2, 3. Print ones. There we go. We have this over here. Now, what if you want to arrange it with arrange? Okay, you can arrange your value just how you want it to be. So, what you can do is, let's say I'm going to put in arr equal np.arrange. Not array, but np.arrange. Okay? Another thing you can see over here is that we have array put over here. Instead, what you can do, you can change these, say zeros, and on ones, you can put in ones. And here I'm going to put in arrange, parentheses, let's say 0, 5, 3. And on the next line, so here, I'm going to type in print, and I'm going to put in arr. That's it. Now run the whole thing. Now you can see sometimes that, it might show you off as an error attribute. You can see np.arrange. Okay? But here, I want arrange, not arrange. So run this again, and there we go. Now you can see we have zeros, we have ones. Okay? So we have 4 zeros, 1, 2, 3, 4 lines, and there are 5 on each and every one of them. In the same way, we have 2 of these, and there are 3 of ones in each line. So this is basically how you can work with arrange. Okay, you can see we have 0, 3, and we have basically removed 5, which is not over here, which is not arranged because 5 does not belong on the index first, but 0, 3, and then 5. Okay, so that is basically how you can work with arrange. Now, the last thing that I want to show you is how you can have even spaced in between the printed one. Let's say I'm going to put in arr1 equal np dot line space. There we go. Basically, it's like linspace, but we can put it like that. And here, let's say 2, 5, 8. So we have 2, 5, and 8. If I print this out, arr1, and you want to run the program, and there we go. We have 2 over here, 2, 3, 3, 4, 4, and 5. There we go. So this is exactly how it is going to start and also how it is going to end. Now, as we're done with this, now let's get into more of the intermediate functions, which are array indexing and also slicing. I'm also going to show you a couple of operations. So let's create another Python file. There we go. Okay. So I'm going to put in array index. So we have array index, okay? First things first, I'm going to put in arr equal np dot array. Open parentheses, secondary bracket should be over here. Let's say I want 10, 20, 30, 40, 50, 60, and also 70. Okay? Now, if you want to index it out, obviously in Python, you know it starts from 0. So basically, it's quite the same. So you basically just print out the arr, secondary bracket. Let's say if I want to print out 30, so we have to count from here 0, 1, and 2. So I'm going to put in 2. Then I'm going to print out. Now, what if you want the last value of the array? First off, put in array, and then put in -1. As this is 0, so if we just rotate all the way back, then -1, -2, -3, -4, -5, -6, and -7. So if we just put it like that, it is fine. Now, what if you want to have a slice? If you want to have a slice, I'm going to put in, let's say, print arr, secondary bracket. Let's say I'm going to slice it from 1 to 4. So 1 is to 4. If you just print them out, you will see that we have np.array. It is not defined, so here I'm going to put in import NumPy as np. Run the program, and there we go. We have 30 and we have 70. And just like I said, we want it from 1 to 3 or 1 to 4, as 4 is exclusive. So 1, 2, 3. And 4 is basically 50, so 50 is removed. Okay? So this is how you can work with 1D array. Now, what if you want to work with 2-dimensional array? If you want to work with 2-dimensional, let's say I'm going to put in arr2 equal np.array. Here, put in 2 of these secondary brackets. I'm going to start off over here. Let's say 10 again, 20, 30. There we go. I'm going to close it off over here. Move on to the next line. Secondary bracket. Let's say 40, 50, 60. That's all. Also make sure to put in a comma over here. So on the next line, I want to print out ARR2. Now, secondary bracket. Now first off, as we're going to work with rows and columns, so starting off, if you put in any value, it is the row. And the second value is the column. So on the first row, let's say 0, put in comma. Which column of data do you want? Let's say 0, 1, 2, 0, 1, 2. So I want 20. So I'm going to put in 0, 1. Now, print ARR2, secondary bracket. Let's say I want 1 and put in comma. And let's say I want 60. So I'm going to put in 2. Now, let's say I want all rows and only column 1. So I'm going to put in ARR2, after ARR2, secondary bracket, colon, comma, and I'm just going to put in the first column. That is how it should look like. I'm going to put in print ARR2. Then I'm going to put in secondary bracket. Let's say 0 is to 2, comma. And next one is going to be, as this is a submatrix, 1 is to, let's say 2. That should work. Now if I just print out the whole thing, this is exactly how it should print out the data. Okay? So now you know how you can work with 1D array and also 2D array. As we have learned about the indexing and slicing, let's also learn about the array operation. So, first off, let's create another Python file. Let's say OPT, that's I'm going to name it. Now, there are arithmetic operations, which are obviously vectorized, and there are array to array operation. So first things first, let's say I'm going to put in ARR equal, first off, let's just put in import NumPy as NP. ARR, and I'm going to put in np.array. Okay? Parentheses, secondary bracket. Let's say I'm going to put in 2, 3, 4, 5. That's all that I need. Now, another thing that I'm going to do is for the next one, put in ARR2. In this, I'm going to put in np.array. Same thing. So we have up till 5. So here, secondary bracket, I'm going to put in 6, 7, 8, and 9. That's all that I'm going to do. Now we have both of these array. But first things first, for the arithmetic operation, I'm only going to use the first array. Let's say print out ARR plus, let's say I'm going to add it up with 6. If I print this out, there we go. It's going to add up 6 to each and every one of the numbers. In the same way, if I put in ARR multiplied with 2, it is going to multiply every number with 2. If I want to divide it, ARR divided by, let's say 2. Run the program. There we go. In the same way, you can also have a power, which is an exponent. So print out ARR, double asterisk, and 2. Run the program, and there we go. We have the exponents too. Now, what if you want to do array to array operation? If you want to do that, let's say I'm going to put in print, let's say ARR, and I'm going to put in space plus ARR2. In this way, it is going to just add up each and every one of those values. And this is exactly how it will look like. If you want to multiply them, print out ARR multiplication ARR2. In this way, it is going to multiply each and every one of the values. It also works with the division. So, just put in print ARR divided by ARR2, or ARR2 divided by ARR, or which is the first value. There we go. We have done arithmetic operations and also array to array operations too. So this is exactly how simple it is. Now, what if you want to do some functions, such as mathematical functions? If you want to do some mathematical functions with NumPy, such as, let's say I'm going to put in print. And after print, I'm going to put in np.sum and then define our array. If I run the program, there we go, we have 14. Now let's say I'm going to put in these values to a stop for now. So we printed out this summation. If you want to do some mean value, let's say I'm just going to copy this, paste it. Now instead of sum, let's say maybe I want a mean value, so I'm going to put in mean and run the program. It will find the mean value. If I want to get, let's say, the minimum in the array, I'm going to put in minimum. This is going to find the most minimum or least value. If I want the maximum value, I put in max and run the program. And also if I want the standard value, just put in std. That's it. There we go. This is exactly how it works. If you want to reshape anything, you put in, let's say, arr3. I'm just going to put in arr3 equal np dot arrange. Let's say 12. And here, I'm going to put in reshaped equal arr3 dot, I'm going to put in reshape. Okay? Let's say I'm going to reshape it with 3 and also 4. And I want to print out the value reshaped. Run the program and you will see it is going to have every values from 0 up till 11 because 12 is exclusive. If you want to flatten any value, then type in print and put in reshaped dot flatten. Open up the parentheses, run the program, and there we go. It will flatten it up in 1 dimension. So this is exactly how simple it is to work with arrays. Now let me just show you a simple project of creating a 3x3 matrix and also compute. So let's just create a Python file. Let's say I'm going to put in mini prj. First off, type in import numpy as np, put in mat equal np dot array. Now I'm going to work with 3-dimensional value. So I'm going to put in secondary brackets. There we go. Let's say I'm going to put in 10, comma, 20, comma, 30, comma, go to the next line, secondary bracket, 30, I'm going to put in 40, 50, 60, comma, I'm going to put in secondary bracket, 70, 80, and also 90. There we go. And that's the end over here. After that, what I basically want is the total sum, the also row-wise sum, and column-wise sum. Okay? So let's just print them out. Let's say total summation, comma, let's say np dot sum. I'm going to put in mat, that's it. I also want to get, let's say, the summation of the row. Here I'm going to put in np dot sum. Okay? Open up the parentheses. Let's say I'm going to put in mat, comma. Now, obviously you know in vectorized data there are 2 axes, x-axis and y-axis. So here I'm going to type in axis equal 1. That's it. In that way, the first row will be summed up. In the same way, if I want to print out the column, so I'm going to put in summation of the column, comma, np dot here, I'm going to put in sum again, parentheses, mat, comma, axis equal 0. Here, just run the program, and there we go. We have total summation, summation of rows, and also summation of the column. So this is exactly how you work with array and also NumPy. So the summary of this class is that NumPy is a foundation of AI and machine learning. It helps you to work with arrays and operations. There are specific essential functions for AI, machine learning, and big data set. And also you can see we worked with, a mini project. So hope you understood about everything in this class. And thank you for watching the video up till the end. If you have any problem or any confusion, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AI, machine learning, data science, and big data set.